Hello everyone. Today we'll be learning about proportionality theorems. The first theorem that we have is the triangle proportionality theorem, and that says if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So we can see an example of this on the right hand side. I see that this side DE is parallel to AC. So that would therefore mean that BD over AD is equal to BE over EC. And so we get a proportion there. And then the converse of this theorem is also true, so I can switch this around and say that if a line divides the two sides of a triangle proportionally, then it is parallel to the third side. And so here I see that I again have that proportion that BD over DA is equal to BE over EC. And since I have that proportion, I can therefore say that DE is parallel to AC. So let's look at some examples of using this theorem and its converse. So for number one, it says in the diagram, QS is parallel to UT. And I can see that in the diagram because of those red arrows that mean that they're parallel. I see that RS is equal to 4. ST is equal to 6, and QU is equal to 9, and I want to find the length of RQ. Well, we know from our theorem that since this line is parallel to that third side, that it divides the two sides proportionally. And so I'm going to take the one side and kind of split it and put it in a proportion and set equal to the other. And so I'm trying to find RQ, and so I see that side with RQ. That fraction is going to be RQ over QU. And that's going to be equal to, here be careful which one you put on top. I want to put the one that matches with RQ on top, so that's going to be this RS. That's going to match. So I'm going to have RS over ST. So we split that long side into two parts. And I want to go ahead and substitute in the different lengths. I don't know the length of RQ, so I'm going to leave that as RQ. QU has length 9. RS has length 4, and ST has length 6. And now I'm going to go ahead and solve this proportion. So I'm going to cross multiply, so I have RQ times 6 to get 6 RQ, and then 9 times 4 to get 36, and then divide both sides by 6. And I get that RQ has length of 6. And then if you ever want to check your work, you could go ahead and plug all those back in and make sure they're equal each other. So this is 6 that we just found. So I have 6 over 9, which if I simplify that fraction ends up being 2/3. And my other one is 4 over 6, which when I simplify also equals 2/3. So I am good. Okay, let's try this next one. So here I want to find the length of YZ. So I again need to set my proportion. I'm going to start with WX on top. You could start with VW on top. Either way works. You just need to make sure you're consistent with the other side. I want to go ahead and do WX. So I have WX over WV is equal to, since I have WX on top on the left-hand side, that means I need to do YX on top because that matches. That's the corresponding side. So I have YX over YZ. WX is 44. WV is 35. YX is 36. And I'm finding the length of YZ. Now I can go ahead and cross multiply. So YZ times 44, I get 44 YZ is equal to 35 times 36, which equals 1260. And I'll divide both sides by 44. And I divide both sides by 44. I get approximately 28.64. Okay, now this last question is a little bit different. It's asking us to determine whether segment PS is parallel to QR. And so here I already have all the side lengths, and so I now need to use the converse, which told us that if these side lengths are proportional, then my two segments are parallel. So I'm going to go ahead and set up my proportion and see if they end up being equal to each other. And so I want to do NP over PQ. And see if that is equal to NS, because remember NS matches up with NP. So NS over SR. NP is 90. And then PQ is 50. NS is 72. And SR is 40. Then I'm just going to cross multiply. So 50 times 72, I get 3,600. And 90 times 40, I also get 3,600. So I do end up with a true statement, so that means that this answer is yes. And just to show you, you could also start with a different side length on top. So you could instead do PQ on top. So I could have PQ over PN and see if that was equal to SR over NS. So you could essentially switch around these and you'll still end up with the same thing. So you'll see in the end, you still multiply the same numbers.